Hey guys, welcome with this movie about paragraph 7.3 exponential formulas. And we were talking first of all about exponential growth in the last paragraph, and then we had tables. And well, with tables you can make graphs, but we can also make formulas, and that was this paragraph is all about. How to make an exponential formula, and if you know the formula, how can you tell if the graph is increasing, going up, or decreasing, going down? Well, if you remember, we had the British COVID-19 mutation and we had a growth factor of 1.3. And the growth factor was basically what you needed to multiply the original number, the old number with, to get a new number. And at the beginning, we calculated with 100 people, so at time 0 we had 100, and then we needed to multiply by 103 to get to times 1, multiply with 103 again, and so on and so on. And under it, you can see how to calculate if you put it into a calculator without punching times 1.3 all the time. For instance, if you need to calculate at time is 4, and you can easier or quicker calculate it if you use this kind of formula over here, because we have we started 100 multiplied by 1.3 to the power of 0, and to the power of 0 is always 1, so multiply by 1 is the same. And then we multiply with 103 to the power of 1, so that's equal as multiplying once with 103, and then 100 multiplied by 103 to the power of 2, that's equal to twice multiplying by 103, and so on, and so on, and so on. And if you want to calculate that with your calculator, there is a nifty button for that. So we want to calculate 100 multiplied by 1.3 to the power of 4. There it is. It is this roof thingy over there. That means to the power. And if you print it into your calculator, you will see that the blinking part in your screen will move up to indicate to the power. Just one more to show you. 100 over there, multiply 1.3, and then the roof thing goes up, and then 4, and then answer. There it is. Okay, if we can use this to calculate it, we can put it into a formula, because basically if we call this time, then time is 0. This is 0. With 1, we see the 1 over there. And with 5, we see the 5 over there. So this number over here is the time. And then it will become 100 multiplied by 1.3 to the power of t. And the 1.3 over here is the growth factor, and the 100 is the original number. So you need to remember, and also put it over here. If you have an exponential format, it looks like h is b multiplied by g to the power of t. The b is the initial amount. The amount at time is 0, where we start with. The g is the growth factor, what you need to multiply is to go from 0 to 1 or from 3 to 4. And as you know, we had some problems with me writing x as not as nice, that it could be a bit confusing if the x was the symbol x or the multiplication sign. So that is why we replace it with the multiplication dot. So I will always write it down from now as h is b dot gt. Okay. The growth factor, the value at t is 0 is b. So you need to work out what the value is at t is 0. That is b, and the G is the growth factor, and the growth factor is always positive. If it is greater than 1, we have an increasing graph. If it is 1, we have a horizontal line. And if the growth factor is between 0 and 1, it is decreasing. It cannot be smaller than 0 or 0 itself. Assignment: make a formula for how many people are infected if the R value is 0.6 and there are 16 infected at time is 0. Hey, see you in class. Take care. Bye.